From KUNC and the NPR network, this is In the NoCo. I'm Erin O'Toole. And today, we're looking at an unusual snapshot of evolution that's happening in real time on Colorado's Front Range. If you've spent even a little time outdoors in Colorado, you've probably heard the song of the mountain chickadee. These adorable, chubby little birds are common in higher elevation forests in the Rocky Mountains. Here's what they sound like. And they have a close relative, black-capped chickadees, which tend to live at lower elevations. They sound a little different from their mountain chickadee cousins. But in areas like Boulder County, the habitats of these two types of chickadees overlap. And that could create a problem. Because when birds from these two distinct species want to find a mate, it's important that they can identify a bird of their own kind. But researchers at CU Boulder say those two slightly different birdsongs are evidence that the birds found a clever solution. The mountain chickadee changed its tune, so it's no longer the same as the black-capped chickadee. Olivia Taylor is one of several researchers at the University of Colorado who have been studying this adaptation.
Songs are very important to birds. They're used for species recognition, they're used for selecting mates, and they're used also to defend their territories and just communicate with one another about potential threats.
She and fellow CU researcher Scott Taylor, no relation to Olivia, joined me to talk about their findings, which were recently published in the Journal of Evolutionary Biology. They talked about how this snapshot of evolution has happened quickly, in part because of humans reshaping the landscape of the Front Range.
We were interested in song as a potential recognition barrier between the two species. One of my first students found that, where you find hybrids between black-capped and mountain chickadees across the whole continent of North America is strongly correlated with where humans have modified the habitat. So for whatever reason, where we've made changes to the habitat, there are more hybrids between black-capped and mountain chickadees than in places that we haven't made those changes. We don't know exactly what changes we're making yet that matter, but our suspicion is that it's the creation of urban forests. So if you think about Boulder County or Denver or any of these regions 400 years ago, there were very few deciduous trees. But now it's basically an urban forest that stretches from Denver to Boulder and up and down the Front Range. And those urban forests are really great habitat for black-capped chickadees. So probably because of human habitat modification, there are more black-capped chickadees here than there would be if it was still just, pine savanna out into the plains and not a lot of deciduous forests.
Right.
So we've probably increased the degree to which black-capped and mountain chickadees interact locally because we've created these urban forests. Black-capped chickadees have colonized those areas, and there's a lot more of them than maybe there were historically. So I think in this case, humans might be, impacting the evolution of chickadee species just by changing habitats in pretty significant ways.
So I know for this study, you had to listen to hundreds and hundreds of bird songs to notice the differences. Scott, is this something an average bird watcher would notice and be able to tell apart?
One thing that started the research was that when folks had visited both California and Colorado, we noticed that the mountain chickadees here in Colorado do sound different. And so Olivia spent her honors thesis work kind of characterizing just how different using actual data and not just anecdote. But yeah, you can hear the difference in the field for sure.
What should we listen for, Olivia? How can we tell the difference?
Yeah, mountain chickadees in Boulder are usually producing 2 introductory notes, which are these really brief little notes, whereas elsewhere they're usually only producing 1. The mountain chickadees in Boulder are also in general just singing more notes per song than elsewhere. And one other feature that we found that was different, which is really hard to detect with our human ears, is that in the first note of the song of the mountain chickadees in Boulder, there's a smaller frequency difference within that note than in mountain chickadees elsewhere.
How did you discover that? Was that just the consequence of listening to 2,000 bird songs, or did you have to kind of run that through an analyzer of some kind?
We definitely had to analyze it. Our ears aren't as good as bird ears, so I wasn't able to audibly detect that difference, and I wouldn't have known about it. But that frequency difference that we looked at is one of the song measures that we were characterizing throughout our analyses. So once we had all of those measures characterize, we plugged them into a bunch of statistical tests and found that that was a significant difference.
I wonder if you could put this study into context. What should people take away from this research?
I think if anyone is interested in preserving the natural biodiversity that we have on the planet, then this research is really interesting and important because it's showing how, in the face of these anthropogenically correlated changes, we're seeing how these two birds that previously weren't in contact are able to continue to exist together. So just understanding how these species are going to adapt, if they are able to adapt in increasing urbanization, is a really important thing to know.
I think chickadees are these common backyard birds. We mostly don't pay attention to them, but they're helping us understand some really fundamental things about how species co-occur, how evolution can, rapidly allow organisms to adapt to change. And, we're seeing unprecedentedly quick change on the planet right now, whether that's urbanization or temperature or precipitation. And so by studying the signaling mechanisms between these two closely related birds and seeing that, yeah, they can diverge relatively rapidly, that probably has an impact for their coexistence, I think it's kind of interesting to learn such fundamental things about evolutionary biology and biodiversity in general from these common backyard birds that, we all, many of us put food out for them and we don't necessarily think about what we can learn from them other than we like to see them and hear them.
Yeah, and this all seems to be happening in a pretty short span of time. I mean, I always think about evolution taking place over thousands of years or millions of years, but, this is happening a little quicker.
Yeah, definitely evolution in response to anthropogenic change can happen really quickly, especially if, for organisms with shorter generation times. And in the context of these birds, there is learning involved as well, which is really interesting. So this learning plus rapid evolution can cause things to change pretty quickly, for sure.
Scott Taylor is an associate professor in the Department of Ecology and Evolutionary Biology at CU Boulder. He's also the director of the CU Mountain Research Station in Nederland. Olivia Taylor is a recent graduate of the University of Colorado and the lead author of the study. We'll include links to their research in our show notes and at kunc.org. And before we get out of here, we want to share a couple of ways that you can interact with the show. First, there is the In the Know Code newsletter, headlines and updates from the KUNC newsroom delivered to your inbox every week. Just head to kunc.org to subscribe. And if you want to tell the In the Know Code team what's happening in your corner of Colorado, you can drop us a line. Send an email or a voice memo if you like to noco@kunc.org. It's also a great way to send feedback to the team that makes the show, whether you liked what you heard or disagreed with something. We want to know. Email us at noco@kunc.org. That's it for us today on In the Know Co. I'm Erin O'Toole. Thanks so much for listening.